This is video number 18 in the series on the Orange Pi 5 Plus, and this will consist of several sessions regarding XY plotters. Don't know if you're familiar, but there was a time when we had computers and we didn't have graphics displays, and we used mechanical plotters to generate graphics. So I want to show you what's available today and what was available at one time. And in order to do this, we go to the web. In 1984, I had an AmPro little board, which was a Z80 based system, a 5 1/4 form factor that was used to mount on the back of a floppy drive or a hard drive. And I remember at that time that board was like $349, and it was a Z80 based system, 8-bit, running at 4 megahertz, I believe. And I purchased a Maxtor 20 megabytes, not gigabytes or whatever. It is 20 megabyte drive. It costs $248. Hard to believe. Also, the board required a SCSI, small computer system interface board, which is probably another $100, so that was an expensive system. I had a plotter, an Amdec DXY-100, and I scoured the web, and this is the only reference that I could find to that board, or excuse me, that plotter. And this is, let me click to enlarge this. This is just the electronics section. Missing is the baseboard or whatever where you put your paper, and then there's a mechanism that moved a pen holder back and forth and up and down across the page. And that's missing from this item here. And if I go back and look down here at the user description of the item, this item has been used previously. Item may have some signs of cosmetic wear, but is fully operational and functions as intended. That is not a true statement at all. So typical of some things that you will find on eBay, you have to know what it is and how it works. So we're going to emulate this thing because it was one of my favorite toys at one time. Let me show you what is available now. If I go and look on, first of all, let's go to YouTube and look at what XY plotters do. Just search for XY plotter, come up with these videos. Here's one where there is a mechanical pen, usually used for drafting. It's 0.35 millimeters, and someone has an XY plotter going, showing a demo here. Here's another demo where someone has a plotter with a felt tip pen generating an image. It's possible for you to, someone has a system set up here to do vertical placement of the paper. There are all kinds of demos here, which you can, if you're interested, go and look at. I'm interested, this one right here has an ink pen that has a hexagonal, oh, excuse me, not a hexagonal, rectangular shaped point that allows you to do fine and wide lines depending on which angle you're going. Let's go look at these plotters here that are available on again on eBay, but this one, these are the way the old plotters used to be, and this one's German made. Back in the 80s, the most popular plotters were done by Amdek, which is now Roland, and Roland is off in the music business. There was Hewlett-Packard. Let's see if we can see an old one here. Here's a HP 7475. This is probably 1984 time frame. $65 used with $65 shipping. Don't know where it's coming from. Don't even know if it's functional. Here's almost $6,000 one, and there are a large number of flatbed systems that are used in industry for cutting materials and vinyls, for making signs on sides of buses and commercial vehicles, etc. But the cheapest one you can get, and I'm not recommending buying this or anyway, but just I'm going to use it as a demo to show you how it works. But you have a pen holder that is moved back and forth across the paper, and a writing instrument. In this case, it looks like a ballpoint pen, and this thing moves the pen up and down with a servo. There are two stepper motors, one here for controlling motion in this direction, and another stepper motor which moves the pen back and forth this way, and you just, as you're moving, you can lower or raise the pen to draw your figure. Here's the details of what each one of the components looks like. There's a board here. This is a controller board, and it has parallel cables that go to the motors, and there's a special servo or stepper motor control chips on here, one to do the X direction, one for the Y direction, and then another that goes off to the pin mechanism. On here you can see the servo mechanism, and it uses a little arm to push the arm up to raise the pin, and then just let it back down to draw. It's rather ingenious design here. There's a whole bunch of other pictures. Here's some stuff that you can do now. That comes with software for Windows, nothing for Linux. So we're going to do our own. Well, I'm not going to do this one, but I'm going to show you how to do XY plotter software on your Orange Pi. This is what it's a kit, so it has extruded aluminum, then these acrylic pieces. There's the two stepper motors. There's some wheels to keep it aligned with the X and Y direction. Then all the parts. There was another thing here that showed, if I can find it, the dimensions. Let's see, where are your dimensions? Oh, here it is. Now it shows here these are the dimensions of the device itself. It's 570 millimeters this direction, but you cannot draw that whole direction. Obviously, there's limits here. And speaking of limits, more expensive XY plotters will have limit switches, so that if the stepper motor tries, and the software tries to move the pin or the mechanism past its maximum dimensions, it turns off power to the motors. All right, I've shown you all this. So, I still need my Firefox here. I did a search of the internet, and I found a software package that was created in C for generating plots using one of two languages. One of them is called DXY-GL for Hewlett-Packard Graphics Library, which was the software that was used on HP plotters. And then there's the DXY graphics language, which was used on Amdec and Roland plotters. Two places, I found two sources. One of them is at github.com. Go to github.com, go over here and search for HPGL to PS. Well, this is a package which takes the HP graphics language and converts it to a PostScript file, and you can send that to a printer or we can display it. This is what we're interested in. Here's the archive, so let's go to the directory there, and then there's a number of files here. The one I'm interested in is the DXY to PS for doing Amdec DXY command language, or graphics library, graphics language. So let's get the whole package. The way you do that is you do a code, select here, right click, go down here and copy. Then we open up a terminal window. Let's get this large so you can see it. This is, we're getting this from GitHub, so I'll make a directory. GitHub, CD into it. Then I do a git clone, and then right click and paste the copy link that I made and do a return, and it goes off and copies it. If I do an ls, I got a subdirectory. Let me move into it if I can type correctly, and there are all the files that we need. There's a make file, there's a readme. I want you to go and do all this. Follow the instructions in the make file, setting up your variables, your machine, and everything. That will create the HPGL and the DXY routines. There's some test files here, and shows you how to run the program and then compare the output with their standards. Let's see if the make file will work. First of all, let's look at it. This is interesting. We're going to work with software we have not written, and it looks like this is done by a committee, modified by several people. So we're going to see if this will work. And the make file set up to do the HPGL to PS, and then there's a DXY. So let's just try it. Make. Do an ls, and it did make the two. It did make the two executables. So the program works. I'm not going to spend some time in this video. We'll come back. I want to test it first. Let's go and get the second routine, and in order to do the second copy, we're going to go to ctan.org. CTAN is the Comprehensive Tech Archive Network, and we're going to look for the same thing, HPGL to PS. Says it's found the package. Click on that, and then here's the sources. Go to there, and we see that it's got this one has a larger number of files. So let's bring those down by doing a download here in one zip file, the archive. Oops, I should have, well, that's okay. that came from C10, so let's do a make directory C10. Let's go to downloads where I downloaded the package, the zip. Let's move the zip file up to the home directory and into C10. CD back to our home directory. Go into C10. Unzip this, unzip. Made a subdirectory HPGL2PS. CD into HPGL2PS. And we've got the same thing, but it looks like I think I said we get more files. There's a make file, make. Oh, we got an error. Too few arguments to function fprintf. Let's see if there's a readme. Yes, there is. Readme. Oh, this is not as detailed. This has only one person involved in it. All right, DXY simple command set was used for all the DXY, that's the MDEC and the Roland plotters, and then RDGL for Hewlett Packard. I'm interested for two reasons in using DXY. Number one, I'm familiar with it from 1984. Number two, it's simple. It's got like 22 commands. The Roland GL or HP Packard command set, it uses 2 letters per command instead of 1 letter per command as in the DXY. And it's a larger set. Because there's 2 letters, it's a little more difficult, I think, to use. So let's keep it simple. We'll go with the DXY. So your job is to download these 2 packages from the 2 places and get both of them working and run the test sets to see what you get. Then I want you to sit and think, get a sheet of paper and think about how using an old DXY plotter or this software on your Orange Pi 5 Plus or whatever system you're using, how it's different from using a real plotter. And I'll come back. You're going to find that the routines will let you change the pin width, that is the line width, but it doesn't cover things such as color, what have you. And I'm going to show you how to modify that. There was one other thing that I forgot here. Let's go back to eBay. All right. And I want to go and look at the spy. Surely you've used one of these as a kid. Probably got one for Christmas. It's an old toy, Spirograph, in which you got a set of plastic discs and some pins, and you could create these fancy patterns. Here's what the contents look like. Here's some examples, but the problem is that you probably had the same problems that I remember, is that this thing was tested your coordination and eye-hand coordination abilities to get one without making a mistake. So we're going to emulate this thing using this software. So that's an exercise. This will take a couple of more videos to get everything working as advertised. So I hope you will be willing to participate. I'm going to show you how to do some things, but I'm not going to show you everything because that would be no fun. So I'm going to leave you to it. Hope you come back for part 2 and 3 and however many there are. Hopefully it won't be too too many. So we're going to keep them all to like 20 minutes. Thank you for your time, and be sure to come back. And I would appreciate a like.